Welcome back to my channel. I'm Brian Kafke, and in today's video, we'll be talking about Databricks Fast Lanes, which allow you to get much faster query execution at lower costs. Let's jump in. Where are we going? Well, I'm going to give you a spoiler alert right at the beginning so you can decide if this video is relevant for you. But the bottom line is it is all about faster queries and lower costs. And then there's a deeper dive into what this actually means for Databricks developers. A couple of disclaimers here. Number one, I am not being compensated in any way for doing this video. It is strictly for the benefits of my viewers. And two, all views I express in this video are strictly my own personal views and no one else's. So let's get to the spoiler alert. This video applies to SQL endpoints only. And SQL endpoints, as you learn, are basically clusters of clusters that are managed by the Databricks SQL Endpoints engine. The idea behind this is optimizing the sharing of these clusters for high concurrency. And an ideal use case would be supporting analytics workloads like Power BI or Tableau. That kind of thing. You have click speed response needed, and you need these kind of queries to slide through quickly, as opposed to waiting for it to process other longer running queries. The details of this will be explained by Databricks Franco Patano, who's a lead product specialist at Databricks. And I'm really grateful for Franco appearing in this video. In this video, we're going to be taking a really interesting deep dive at a new service that's on Databricks. I'm going to introduce to you a lead product specialist named Franco Patano, who's going to explain this to us. And he's got a wealth of data and software engineering experience, and really grateful to have him here. So thank you for appearing on my channel and doing this presentation for us.
Thank you very much for that introduction. It's very kind. My name is Franco Patano, and I am a lead product specialist at Databricks. Today, I want to talk to you all about a new feature that we've released in Databricks SQL that we call Fast Lane just internally, and I like the name. So I'm going to tell that all to you, but it's really just built into our Databricks SQL product. And you just start using it. There's nothing to really do. What is Databricks Fast Lane? If you know anything about how Databricks works behind the scenes, it's essentially Spark's scheduler that's behind the scenes scheduling all the tasks. And quite typically on a Databricks SQL endpoint cluster, there are 10 slots for the queries to take. And typically how this works is traditionally in Spark, you have the FIFO method, and then you also have a FAIR method. And if you've messed around with Databricks before, standard clusters are FIFO, high concurrency, the old high concurrency clusters are FAIR. And essentially, this was how it worked for a really long time. But something that we noticed when we were working with customers on BI style queries and workloads was that shorter queries were being stopped up by longer running queries. And so our engineers took a look at this and could we make this better? And this is kind of what we thought of, was what if we cut up the resources on the endpoint clusters? And what if we gave short running queries a different lane? And we call that fast lane. But there's another lane. It's not really a lane, but if it's a really short query, it doesn't actually even wait. It just has a little bit of resources to execute. And what this is for, think like metadata queries. Modern BI tools send a lot of short running queries for metadata, and they need to get that back before they start processing the big data. So that's typically why we allow the bypass lane, just so that those metadata queries can finish really quick. And then short running queries are given dedicated resources to process so that they can finish quickly. And then long running queries are given fair access to resources to finish, in an appropriate amount of time. And so the goal here is that to let short running queries process faster than they would have before if they were waiting behind long running queries. But what is a SQL endpoint? A SQL endpoint is a simple way to execute SQL statements on Databricks without having to manage the complexity of clusters or all that stuff. Essentially, we manage the concurrency of these endpoint clusters for you behind the scenes. It will scale up and down as necessary to handle your high concurrency needs. And built inside of these SQL endpoints is the new vectorized execution engine that Databricks has built from the ground up. We call it Photon, and this is what gives you low latency on the queries that are running on these endpoints. So essentially, with Photon and the scaling endpoint that we've built in for SQL endpoints, you can now do low latency and high concurrency workloads on these Databricks SQL endpoints. And what does that look like? Essentially, a Databricks SQL endpoint is kind of like a connector, a compute layer for you to get to your data quickly that's on your data lake or your lakehouse. And you can connect up to these endpoints via JDBC, ODBC, or you can use Databricks SQL inside of the product. There is a query window from an open source project called Redash, but you can use the application, or you can use any application like Power BI if you'd like, or Tableau or ThoughtSpot. And essentially, you connect up to the endpoint with JDBC, ODBC, and then it'll service all your queries. And then you can see here at the bottom, the endpoint scales during the day. So as users come in the morning, it scales up to handle their queries. As users leave for like lunch during the middle of the day, the endpoint scales down. You're not paying for compute that you're not using. And then as the users come back to work, it scales back up to handle their demand. And then as they leave for the day, the endpoint goes back down. Databricks behind the scenes is looking out for your best interests in the cloud, ensuring that you get the best price performance and you're not paying for idle compute. How does this work? If you have a big job that comes in into the endpoint, it's going to go into the longer running queue. And then if you have short queries that come in, it will go straight into the express queue. And if you have medium size or regular queries, they'll go into the regular queue. And they all have their own queue to process. And this is what we think helps manage the concurrency of many, many queries, handling high demand better on these endpoints. Does that really actually happen? Let's find out. Let's take a look at some of these things in practice and see what happens.
A good use case for this, and probably the primary one, would be things like Power BI and Tableau, where they want that click speed response and you need to be able to respond quickly and get queries. And as you mentioned, metadata queries in particular are going to fly through now.
Exactly. Yeah. So what the whole concept is exactly that. Like think of a BI dashboard in Power BI. Before it can actually execute the query, it has to call out to the endpoint and do a bunch of metadata query lookups to figure out where all the data is. And then it issues the big query. From that perspective, we theorize that dashboard refreshes should be execute more efficiently now, and the user should see them refresh better because the short running queries essentially get instant access to resources instead of having to wait. That's the theory. Let's see if it actually holds water though, right? What we're going to do here today is I'm going to do a test. An industry standard test for doing query serving performance is TPCDS. TPCDS is a query serving benchmark, and you can do it for like a power run traditionally. But what I'm going to do it is I'm going to send multiple versions of this power run, the 99 queries that is the benchmark for TPCDS. I'm going to send 5 of them, 5 of these 99 runs in parallel and repeated 40 times.
So it's almost 500 times 40. So you're sending what, like 20,000 queries at the servers, basically.
Exactly. I'm overwhelming it. A lot of customers ask, what's the limit of these endpoints? You know, the marketing people like to say they're limitless. I like to say it's near limitless. The real limit is the IP address space that you have in your VNet or your VPC or whatever cloud you're on, whatever your networking boundary, whatever how many IPs you can address, that's your limit. So essentially, this is the data we're going to be looking at today is TPCDS. And I just kind of want to show you what it looks like. You have a sense of the data volumes that we're talking about. This isn't small data, but this isn't really big data either. I call this average data because when I interact with customers, I find that everyone pretty much has medium-sized data. This kind of shows that. We're dealing with fact and dimension tables. You know, the return tables is about 11 gigs. I think the web sales table is the biggest table.
That's like standard customer type data.
Exactly.
Right.
Yeah. I think it's like 100 gigs of warehouse data that's in this thing. That's what the data looks like. And I just kind of want to show you the Data Explorer. It's this new tool that's baked into Databricks SQL, and I think it's great. It allows you to view the schema of all your various tables that exist within inside of your lakehouse. You can browse what the data looks like. You can even look at the history if it's a Delta table. And what's like the first thing you do when you go into a database is you right click, select top 1,000 star,
right? Exactly.
Right? And I want to look at the data. Let's get into it. What were the results? We sent, all those queries. We tried to overwhelm these endpoints. What happened? And how was the query performance? So first thing that I want to show you is what is the difference when we're testing the fast lane versus the baseline. So what's in the current channel versus what's in the preview channel. Because with Databricks SQL, how we release new software is that we just release it to a channel, but we give you the opportunity to test the next release in the preview channel. So that's what I've done here is I basically ran the same tests on 2 endpoints, and I gave one the regular channel and one the preview channel. And I wanted to see what the difference was with Fastlane.
So these are deltas. This is the difference between the queries shown on a diagram, and then you're averaging it out, correct?
Exactly. I want to know what the average difference is. But remember, this isn't just one run of the queries. There's 99 queries repeated 40 times, 5 times in parallel.
About 20,000 times.
Exactly. So there's a lot of runs in here. So this is on average. And so when I first saw this, I was like, this doesn't tell me very much. Actually, it tells me that just by looking at this, I think query performance got worse. And actually, when our expert performance engineers did just the power run of TPCDS, this is what they saw. They were not impressed. And they were like, what's going on here? What did you guys do? And then I was like, wait a second. What they did, if you think about Fastlane, was they optimized the total load on an endpoint. One run of TPCDS 99, what happens if we actually overwhelm the box? Does it just because it's on this end of the spectrum, it gains some time? And just because this query is on this end of the spectrum and it lost time, does that mean that they always performed poorly or performed better? So I didn't think this was enough data.
What you're seeing is the average difference, meaning average performance, either better or worse, over about 20,000 executions of the queries on either side. And so you do see that on the left, it's actually worse. It went down. On the right, it went up. But it's important to remember this is an average of all the query executions. Sometimes the same exact query, depending on exactly when and how and what it's competing for in resources, will run a little worse. The other part of it is because it's an average, you're not seeing, well, what type of query is each one? What's going on? So the key to this is there is a bit of, what they call robbing Peter to pay Paul type of thing. You're trading off. You want to let some of those shorter queries get through quick. And you are willing to take a hit on some of those really long queries.
Users expect short queries to return fast.
Right.
And the expectation is long queries will take longer. So make the resource allocation align to the expectations. Exactly. I want to pick one from one end of the spectrum, and let's take a look at the profile of all those runs. We're going to take a look from the other end of the spectrum, and we're going to pick from the middle of the spectrum, just to show you that this chart actually doesn't tell you anything. The performance is much more interesting than what meets the eye.
If I could go up to the top just to where you have the parameters, because I wanted to show the parameters that you're using. So on the left, you've got the baseline classic, which is not changed. The second one is you want to compare that to the endpoint, the new one, which is Fastlane, and you're picking query 20 out of the 50 or so queries that are there. So you're going to say, I just want to look at a slice of this, what's happening there. So I just want to show that. Then when you scroll down, we're looking at a really granular view of just that query.
Exactly. This is the all 99 average diff.
Yep.
And then when you select a query here in this box,
Yep.
It takes that one query and it looks at the life of that query over all of the runs.
Which is a nice demo of the visualizations too that you can do here.
Yeah, this is Databricks SQL. It's actually pretty nifty. What we're looking at here on the left, we're looking at the spread, the min, max, and average of all these query runs over all of their runs. And what I want you to notice here is that this query was at this end of the spectrum, but it does not always execute that fast. It doesn't always have that average diff. Actually, the min on this, the versus Fastlane versus current, is right around the same. Actually, it's a little bit faster on Fastlane, 1.78 versus 1.94, but like milliseconds faster, right? Actually, on average, it does execute about 10 seconds on average. So that's typically why it's there, but not all the time. Actually, it does max out at about 255 seconds on Fastlane versus 200 on current. That means that this query does take longer than its min. These queries do not execute the same at all points in time. And that's why we want to look at the one on the right here. What this is showing us is this one query with the two tests. And the X is the start time and the Y is the end time, because I just want to kind of separate out the runs so you can visualize what's going on here. And the bubble size is the duration. Where it's falling XY actually just means when it was executed in the run. The point I want to get across here is that it's managing the resources more effectively. And we can infer that because this query does not run the same every single time. It matters what else is going on the endpoint. And this is the story, right? I want shorter queries to cut in front, but there's actually a stopgap. We also don't want to starve long-running queries for forever, right? Because that means that they're not getting the resources they need. So let's go the other direction. Let's find one on the other end of the spectrum, query 67. You would assume that this query would perform poorly all the time. It's very interesting on this one, is that in the current, it's at the min is better. So if this query executes faster in the minimum side. So on the lowest side in Fastlane, it also performs the worst compared to baseline. And this is because it matters what's going on the endpoint. It matters what other queries are currently going on and how long they've been executing. Yeah, performance got worse on average. But actually, if you look at the min and the max, this query can perform really, really fast. With Fastlane, as it's finishing up the shorter running queries, it does give the longer running queries resources to execute, and it can actually execute in its min during certain times of the load. Your short running queries are getting access to resources, but your long running queries aren't starving. So now I picked a query from the middle of the spectrum, right? This query on average, it was immaterial, the average difference. But when we look at it on aggregate, that's not the same story, right? When we actually start diving in, the average query difference is less than a second. So you can see here the averages. But what's very interesting about this, the minimum time that this took to execute in Fastlane was 1.28 seconds versus 2.13 seconds on current. What that tells me is that Fastlane will give shorter running queries the opportunity to run faster. The endpoint understands the load that's going on all the clusters at that time, and it's distributing resources accordingly, but it's not starving anyone. With Databricks SQL, you can run these endpoints on Spot, which is a great price performance. And I ran these on Spot. Spot has up to 80% cost savings, but the thing is, it's like access compute. So it's compute that no one's using, and they're going to give you a discount if you use it, right? But they could preempt your instances, meaning, hey, your discount's over. Somebody else needs this box and they're going to pay full price. We're going to give it to them. And we run the workers on something that's called Spot Fallback on Demand. It's basically playing arbitrage on cloud instance pricing. We'll run it on Spot. And if the spot market fluctuates, we'll flip it to on demand. It understands the queries that are coming in. It will only boot the amount of instances required to clear the queue. So It's smart about scaling up. So we're really looking out for your costs on the back end to make sure you're getting the best price performance in the cloud.
But people who want to take advantage of this, the one strange thing to me is you really don't have to do anything special. There's no extra coding. Mm-hmm. There's no special things. And probably by the time people watch this, it'll be in the default queue where you create your clusters from for SQL endpoints. So people will just be getting advantage of this. But if you want to kind of know how the performance is improving and you want to be preparing yourself more for those data warehouse loads, this is a really good thing to know about, because it means you need to look now at it and in the future, not what it may have been like 6 months ago.
Yeah, the largest investment area in Databricks today is Databricks SQL, and we are hyper focused on delivering the Lakehouse vision, which is essentially, low latency, high concurrency serving off of the data lake. So this is absolutely critical to that. So over the next 6 to 9 months, the things that you can expect that are just going to happen in Databricks SQL, you're not going to have to do anything. And this is the vision of Databricks SQL, is that it's simplicity out of the box, good performance. You don't have to, do all the knobs that you're used to in Databricks. So it's a completely different paradigm to what people are used to. But in the coming months, you can look forward to even more innovation, and it just comes. Endpoint clusters are going to start booting significantly faster next month. Actually, it'd probably be a few weeks out, depending upon when your viewers watch this video. We're working on decreasing the boot time of these endpoints. And then coming out, later this year on Azure, we have serverless. So serverless is instantaneous boot, something similar to other vendors who have serverless. But the compute is in our account, so it's a little bit of different architecture than classic Databricks customers are used to. But essentially, there's a lot of innovation coming to Azure Databricks SQL over the next 6 to 9 months. You should definitely pay attention. You don't have to do anything to do it. It's just going to start looking and feeling a lot better. And you just gain all the benefits of that as a customer if you're using it.
All right. Well, I want to thank you for presenting and telling us all about this exciting new feature that is just sort of hidden there waiting to be used.
Thanks for having me, Brian. I really appreciate it.
Wrapping up, we learned about Databricks SQL endpoints, which are essentially clusters of clusters, all managed by the Databricks SQL Endpoints engine. A common use case is when you want to use Databricks SQL Endpoints as a way to manage high concurrency, right? Lots of different queries of different degrees of resource consumption and expected time to take to execute. The biggest problem with this is getting analytic workloads to run quickly. all these metadata queries and quick hits that you need to slide through quickly and get back out of Databricks would sometimes get kind of blocked and slowed down in the past. No longer with Databricks Fast Lane. That's really its best use case, as well as situations where the cluster has such a varied use where you've got people who are really just trying to get like 100 rows back and do some development work at the same time as other people who are put in through very heavy workloads. So it's really designed for that and getting the optimal use. I was lucky to have Databricks Franco Patano give you a detailed explanation with visuals and all that cool stuff to explain why this is so cool and why it works. Again, faster performance, better management, lower cost, nothing you have to do on your end. I believe at this point, Databricks Fast Lanes is already in production by default. So by the time this video comes out, it should be available and should be able to be really already using it without having to do anything. Thank you. Please like, share, subscribe, especially like. That helps my metrics. Let me know in the comments what you think of this, what questions you have. I always review those. Until next time, I'm pulling for you. We're all in this together.